Introduction to robotics, control of a servo motor using using Arduino, and we're taking here the knob example. For building the circuit for the control of a servo motor using a potentiometer, we would require the following components. First of all, of course, we would need an Arduino microcontroller. We would need a servo motor, a breadboard, hookup wires, and a USB cable type A to B, and finally a potentiometer. Now, servo motors, they come with certain specifications. For example, the one we selected here, it's a micro servo motor. It means it's a small servo motor which weighs about 9 grams, plus minus 1. And the maximum torque that can be handled with this servo motor, as we can see here, is about 2 kilograms centimeters. For this motor, we have the maximum torque being equal to 2 kilograms centimeters. So this, however, sounds a bit strange, because in mechanical engineering, we know that torque has the units of Newton meter. However, in data sheets and specifications of servo motors, you are more likely to see the units of kilograms centimeters. So what do they mean exactly with this? So if we take this example again, which is a maximum torque of 2 kilograms centimeter, it simply means that the motor can raise up or move up a mass of 2 kilograms when it is hanging at a distance of 1 centimeters from the center of the shaft of the motor. Again, it simply means that the motor can raise up a mass of 2 kilograms when it is at a distance of 1 centimeter from the center of the motor shaft. When you substitute these numbers into the formula that we know from statics, where the torque is equal to the cross product between the position vector and the force vector, and we write it down as RF sine theta, the angle between both vectors, and this can be written as FD, where D now becomes the perpendicular distance, because R sine theta is the perpendicular distance. And what would be the force here? The force would be simply the weight of this object here, in this case mass times the acceleration due to gravity, and then we need to multiply this, of course, by the D, perpendicular distance. So the torque would be, in this case, 2 kilograms times 9.81 times 1 centimeters. Make sure that you use consistent units. So we have to divide it by 100 to turn this into meters, and you will get that the torque is about 0.1962 Newton meters. So as a rule of thumb, usually whatever value you have in kilograms centimeters, just divided by 10, it will give you roughly the value of torque in Newton meters. Breadboards, these are units that are used for building the circuit, the electronic circuits, and the advantage of using these units is that you wouldn't need soldering, and this is very important when you're still at the prototyping stage. And as you can see here, so it's plastic. We have a plastic cover with multiple holes, and beneath these holes we'll have metallic pieces with certain clips here. And the whole idea is that the horizontal holes are connected together. You can see that these holes will be connected together, and the ones here on the right are connected together. We have on the other side, we have vertical, the holes on a vertical line here. They are connected together here. So all of the holes here on this line will be connected, connected, physically connected together, and we can designate them with a negative sign here, and we can have all the holes here on this vertical line also connected together, and we can designate them with a positive sign. Positive and negative here, they correspond to the voltage and the ground. Here we have a picture of the microcontroller, the Arduino Uno, that we'll be using in this tutorial. The microcontroller is basically a programmable device that takes in certain input, can process it, and will give out certain output. It will have processor inputs, outputs, as I said, and microcontrollers are found in cellular phones. They are found in remote controls, in washing machines, in microwaves, in car engines, and in many applications. Not necessarily exactly in this form. On the other hand, we have the servo motor. Servo motors, usually they end up with a socket, like in this one, where you can push in jumper wires, and you will have 3 wires. One would be a red wire, which should be connected to the 5 volts pin on the Arduino board. We'll have a black wire, which should be connected to the ground pin on the Arduino board, and a yellow or sometimes an orange color that should be connected to one of the pins on the Arduino board. In this case, we're gonna connect it to the digital pin number 9, but not necessarily. It could be to any other pin. So as a summary, we'll have to connect 3 wires to the servo motor, 1 red, 1 black, and 1 yellow. The red corresponding to the voltage, the black to the ground, and the yellow to the signal. Here we have the connected circuit. You can see that you would need to connect a 1 wire from the servo motor, and it's better to choose a red one so you can keep track of the connections. And this is towards the 5 volts because this servo motor operates on a 5 volts. And we'll have a black wire connected to the ground. Could be this one, either one should be okay. And we'll have a wire from the servo motor connected to the digital pin number 9 here. Here we have the circuit as we connected the wires from the servo motor to the breadboard, and then from the breadboard towards the microcontroller. Of course, it would have been possible to connect the wires directly from the servo motor towards the microcontroller. However, we're going to use the breadboard here because still we need to add other components. In this case, we're going to add the potentiometer, and in the next lecture, we're going to add other servo motors. So it's very important to understand how to connect the wires to the breadboard and then from the breadboard to the microcontroller. So you can see that we have the black wire here, which should be connected to the ground of the microcontroller. Is first connected to, you can select any row of holes here. They are all connected together. So we have this wire now to this hole. We have it here, and then we got another short black wire and to connected it to any other hole in the same row. So you have 1, 2, 3, 4, 5, 4, because this is already taken. You have 4 different options here, so you can select any one of them. So from here, and then you're gonna take it and connect it to the negative. So these holes here on the top, in the second row here, all connected together. They have a designation of negative, which of course is optional for you, but it just gives you a guide as a guidance to connect it to the ground. And then we have the red wire now connected to another hole here, and then we had another short wire from another hole on the same row. Now in this case we were gonna connect it to the positive row of holes on the top, which the positive corresponds to the line connected to the voltage, in this case to the 5 volts. Then we have the orange wire here, which corresponds to the signal wire, and we have it on this row. And then again from any other hole on the same row, we're gonna have another wire that goes all the way towards the microcontroller to pin number 9. So we'll have from the microcontroller here, we will have the signal sent through here, through the breadboard, and then directly to the servo motor to control the angular position of the shaft of the motor. Here what we did is we added the another wire to the 5 volts here on the microcontroller. The red one here, you can see it's in the same row that we have here. So all of the components or wires hooked up to the holes on this row on the top will have will get a 5 volts. And then we had another wire also from the ground on the microcontroller toward the second row here. So all of the components or wires hooked up to the holes on this row will also be connected to the ground. Here we have the potentiometer. The potentiometer includes an adjustable variable resistor, and which can be manually controlled by simply rotating the knob here. And it has 3 pins. One would be the outer pins are could be one connected to the power and one connected to the ground. And by the power I mean the 5 voltage. And the one in the middle would be connected to the analog input 0 on the Arduino. So this is how a schematic of the connections for the potentiometer. We have a black wire connecting it to the ground, a yellow one connecting it to the A0, the analog in, and a red wire connecting it to the 5 volts. Now you can see that here, if we are connecting both the servo motor and the potentiometer directly to the microcontroller, this would not be possible, because we have both of which the servo motor and the potentiometer would be required to be connected to the 5 volts. This is why it makes much sense to use the breadboard as we did before. So this is the same circuit as before, but we just added the potentiometer here. So you can see the 3 pins of the potentiometer were inserted in the holes in the breadboard, and from the same row for each hole we had one connected to the negative row, which corresponds to the ground, and another one here was supposed to be red, but I didn't have enough red wires. That's okay, should be okay. So the blue one here is connected to the positive or the 5 volts line. Then what you need to do is to download the Arduino software. This is, you can find it in their website, arduino.cc. From here, software downloads. You get different options, so you select the one most suitable for you. Now, after you run the software, a window will appear looking like this. in which we have the pieces of code should be inserted somewhere here. And any code in Arduino would consist of two main blocks or functions, the void setup and the void loop. However, in our case, we already have a built-in code within Arduino itself. If you go to examples under file, the pull down menu, go to examples, and you keep going down until you reach servo, and from servo you'll find that there are two examples, NOP and sweep. So for today we're going to consider the NOP example. So just click on the NOP example. So the code will appear here for the NOP example. So we have the heading. Within the heading, we could have certain information like who developed the code, etc. We will have also some global variables defined. The servo here. So we have a servo motor, and we called it my servo. You could call it anything else. Here we have designated that the potentiometer is connected to the analog pin number 0, and the value read from this analog pin will be VAL. Then we have the void setup function. The void setup function is executed only once, and here what we have, my servo.attach 9. It means that the servo motor is attached to the digital pin number 9 in this case. And then we have the void loop. The void loop, from its name, it's going to be continuously performed and with no output. So what would happen is that it will continuously, first of all, read the value from the analog pin, in this case, which is connected to the potentiometer, and then this value would be mapped to a value between 0 and 180, because our servo motor can move from an angular position of 0 up to a maximum of 180. Then the command is sent to the servo motor, and there would be a delay for about 15 milliseconds to make sure that the servo motor already moved that certain angle, and then it will go back and wait or read again the value from the potentiometer and so on. So this is a continuous loop. Just before sending your code and uploading it to the microcontroller, it's really worth it to double check to make sure that you have the correct type of board selected. So in this case we have Arduino Uno, and you also want to make sure that you have the correct port also selected. And this is, and usually you can double check this by removing the USB cable and checking which one would disappear from the list. Now, then you need to click on this button here to upload the code to the microcontroller. So what will happen now is the code will be compiled and converted from the C language to the machine language and uploaded to the microcontroller, and then it will be run on the microcontroller itself. And you could even disconnect the USB cable in case you have an external source for power, because the USB cable also can be used for powering up your microcontroller. Here we have a video showing the assembled circuit. So by really rotating the knob left and right. So let me do it again here. To the right or to the left, you will see the servo motor moving accordingly.